Okay, welcome to today's video lesson. It's 4.5 linear equations, and put today's date. Today's I can statement is I can identify linear equations and write linear equations in standard form. So if you think back to 4.4, the lesson we just finished, we were able to make a table, and when we graphed the ordered pairs, our ordered pairs plotted on a coordinate plane made almost like a line. So today we're going to talk about those type of equations. And the big word for it is called linear. And linear means lines. And if you look, the very first four letters of linear is line. So linear means line. So linear equations are equations for lines. So once again, linear means line, so it's equations for lines. So to be a linear equation, it has to follow 6 specific rules. So it can only have 2 different variables, usually x and y. It can be different, but usually for what we'll see, it'll be variables x and y. Okay, you can only perform the operations add, subtract, multiply, and divide. Only those 4. You can't have square roots or exponents or anything else. You cannot multiply or divide 2 variables together. So that cannot multiply or divide 2 variables together. You can multiply or divide numbers. You just can't multiply or divide 2 variables together. Variables cannot, so that word not again, be denominators. So that means they cannot be on the bottom of a fraction. They have to be on the top. And our last one, cannot have variables with exponents. Once again, cannot have exponents. So next we're going to compare some examples of what is linear and what is not linear. So we're going to have 2 columns, and the first thing we're going to do is look at what type of equations are linear and explain why. So our first example is y equals 2x plus 4. And that's because we have our y, he's off to himself over here on the left. We have our equal sign, and then we have our 2 and x side by side, which means they're being multiplied. And remember, we said we could multiply numbers and variables. We just can't multiply 2 variables. So we can multiply 2 times x plus 4. So we're still good. Okay, our next example has 2x plus 3y equals 6. And once again, we have a number and variable being multiplied. We're adding. We have a number and a variable being multiplied, and we equal 6. So that's good. That's linear. Our third example is x equals 2. And it's linear because it has a variable x, and you don't have to have 2. You can just have 1 variable. At most, you can have 2. So that's why that's linear. And our last one is y equals x divided by 4 plus 6. And this is linear because x is on top here. So x can be the numerator of a fraction. He just can't be the denominator. So we can divide by a number. All right, now let's go on to our not linear. Our first example is y equals x squared plus 4. It's not linear because you're squaring it. Our second example is 18 equals xy plus 4. And it's not linear because x and y are side by side, meaning they're being multiplied. And we cannot multiply 2 variables together. Our third example is the square root of x plus 2 equals y. And that's because we cannot take the square root. The only thing we can do is just add, subtract, multiply, or divide. And lastly, we have our 2 over x plus y equals 3. And that's because variables cannot be denominators. So that's examples of what's linear and not linear. Now once you know something's linear, you can write it in something called standard form. And standard form is one way to write a linear equation. And it looks like this right here. Okay, so ax plus by equals c. And in standard form, our A, B, and C are going to be numbers. So the only thing that stays variables there is just your x and your y. Like we said, linear equations have two variables, x and y. So standard form is one way to write a linear equation. Now, standard form has its own set of rules. So rules for standard form. There's three big ones we have to follow. Our first rule is that A has to be greater than 1. Okay? Sorry, I actually found a typo there. It says A has to be greater than or equal to 0. That was my fault. I found a mistake on there. So A has to be greater than or equal to 0. So if you think about A being greater than 0, that means you cannot be a negative number. A must be positive. So A must be a positive number. He has to be greater than or equal to 0. So that means he can be 0, which means he's hidden. But he just can't be a negative number. Alright, our second rule is that we're not allowed to have any fractions. No fractions at all. Okay? And if you think about fraction bars meaning to divide, if we're not allowed to have fractions, that means the opposite is to multiply. We'll need to know that here in just a second. And our last one is GCF among A, B, and C has to be 1. So our GCF among A, B, and C has to be equal to 1. Now this is just a real quick reminder about what GCF is. GCF is greatest common factor. And we've heard that term before, but greatest common factor means that the largest number that can go into all numbers evenly. And the word evenly here is key. So GCF is our greatest common factor, and it's the largest number that can go into all numbers evenly. And that's our standard form. So the rules for standard form, A has to be greater than or equal to 0. No fractions, and your GCF has to be 1. That means the biggest number that goes into A, B, and C has to be 1. Alright, so let's look at some examples of these. So examples. Example 1, and we're asked to determine whether each equation is linear. If so, write in standard form. So we're going to look at the first one here. Now just right beside of it, we have y equals 5 minus 2x. It first wants to know if it's a linear equation. I have a y out here by himself. I have 5 and a subtraction and then a minus 2 times x. I'm allowed to multiply variables and numbers. I'm subtracting, so we're good. So yes, this is linear. Now, to get it in standard form, so if so, write in standard form. I always like to come up here and write ax plus by equals c and match up my equal signs so I can kind of see what needs to be on the left side, what needs to be on the right. So ax, that means my number with my variable x needs to be in front over here. So if that's a negative 2x here on the right side and he wants to be on the left, he comes across, and because he jumps my equal sign, he becomes a positive 2x. I drop down my y because he's already where he wants to be. See, y is already where he wants to be beside the equal sign. So plus, because he's a positive, y equals, and the only thing left over here is my 5. And if you remember, c's just a number, so 5 is just a number, so we just drop him down. Then we go back through and make sure we're good. So I have x in front for my ax plus by. I have my y second. Y is second. And then lastly, my number is on the right side. So now we check our rules. Is A positive? Is C greater than or equal to 0? Yep. So rule 1 for standard form, check. Rule 2, no fractions. I don't have any fractions, so we're good. And rule 3 is that GCF has to be 1. And the easiest thing to say about this is if I have 2x plus, how many y's do I have here? I have 1y equals 5. So if that's a 1, then that automatically means my GCF is 1. So now we're going to list out what A, B, and C are so we can see. So remember, A, B, and C are just numbers. So A is what's in front of my x, so that's 2. B is what's in front of my y, and it's 1. And C is what the number all by itself, and so C is 5. And we're good. We box in that whole thing. This whole part's our answer. Alright, so example 2. We're given 2x minus 5y equals 6. So first step, decide if it's linear. So is it linear? No. Oh, let's try this again. No, it's not. Because we have x and y being multiplied. And x and y cannot be multiplied. No variables are allowed to be multiplied together. So we could guess our first examples. Number 1 was yes, so we got it in standard form. 2 is no, so we just stopped there. Alright, example 3 gives us 3x plus 9y equals 15. So is it linear? I have a variable and a number, so that's okay. I have a variable and a number, and that's okay. And I equal a number, so we're all good. So yes, this is linear. Now, we have to get it in the standard form. So once again, we're at my standard form above it and match up my equal sign. So ax plus by equals c. Okay, if we look at it, it looks like we're good to go. We see our x is in front, plus, and then we have our y's next, equals c. So we're already in standard form. We just have to check our rules now. So step 1, make sure a is not a negative. A is positive. It's a positive 3, so we're good. Step 2, no fractions. So I'll look across here. No fractions, so we're good. And the last one, 3, says check for a GCF of 1. So my smallest number here is 3. So let's check it. Can 3 go into 9 evenly? Yes, it can. 3 times. And can 3 go into 15 evenly? Yes, it can. So that means 3 can go into all these numbers evenly. So my GCF right now is actually 3. So I'm going to have to divide everything up here by 3. 3's cancel. X plus 9 divided by 3 is 3. Our y drops. So 9y divided by 3 is 3y. Equals 15 divided by 3 is 5. Now we come down here. Remember, if I just have 3 divided by 3, that means it's actually a 1x. So my GCF is now 1, because 1 there. And we can just come across here and set our A, B, and C now. So A is 1, B is 3, and C is 5. We box in this whole answer. Now, our very last, fourth, and final example is 1/3 y equals a negative 1. Okay, for the last example, if you look, it only has one variable. Okay, and with that one variable, we look and we say ax plus by equals c. And we don't have an a, so it's automatically 0. So I do have a 1/3 y equals negative 1. Now, what's wrong with it? I have a fraction. Not allowed to have a fraction. So if if 1/3 and y are side by side, that means they're being multiplied. So I divide both sides by 1/3. 1/3s cancel. y equals negative 1 divided by 1/3 is negative 3. So our A is 0 because I don't have an x. B is 1. C is negative 3. And we're finished.